Hello, Advanced Algebra 2. Welcome to the Concept 39 Notes, Part 2. We're going to continue with multiplying and then look at dividing rational expressions. All right, look with me at A. And if we examine these rational expressions, you'll see that we do have some factoring to do. Now, in the denominator, x cubed minus 27. And 27, you can think of it as 3 that's being cubed. So there is a way to factor the difference of two cubes, but it takes a formula, or we call it a pattern. So I'm going to write this now on the video, and you need to get this in your notes because there's not a process that I can teach you to factor the difference of two cubes or the sum of two cubes. You just want to memorize this pattern. So for the difference of two cubes, we'll call it a cubed minus b cubed. You figure out what's being cubed, what values are being cubed. So in this example, it's an x that's being cubed into 3, and then it will break down into this pattern. So a minus b times a squared plus ab plus b squared. So likewise, if you have the sum of two cubes, it will factor as a plus b times a squared minus ab plus b squared. So let's apply this to problem A. So in the numerator, we just have x plus 2, but in the denominator, we have an x that's being cubed and a 3 that's being cubed. And we'll think of those as our a and our b term. So our numerator is x plus 2. Our denominator will factor as x minus 3 times x squared plus 3x plus 9. And that just so happens to match the numerator on the right, and I'll write that as a rational, put it over 1. Now we can divide out common terms. So notice those quadratics divide out, and we're left with x plus 2 over x minus 3. For our domain rule, we go one step up before we simplified and say that our domain cannot equal positive 3. Now, to find the value that would make that quadratic expression 0, we're going to set it equal to 0 and solve. And I'm going to use the quadratic formula because this will not factor. So it's the opposite of b, negative 3 plus or minus the square root of b squared, which is 9 minus 4 times 9 all over 2. So simplifying that, I get negative 3 plus and minus the square root of negative 27. And finally, negative 3 plus and minus 3i times the square root of 3 over 2. So in this case, we need to exclude two imaginary values. Now I wanted to go ahead and do that because those of you who are working towards taking the Algebra 2 EOC, oftentimes they will have some work with imaginary numbers in it. So I just wanted to review that. Now look at B. This is just two simple rationals that we need to multiply together and simplify. So let's multiply our numerators together. 3 times 6 is 18. It'll become x to the 6th, y to the 4th, over 72, x to the 4th, y to the 2nd. Remember, the shortcut rule with multiplying same variables is to add the exponents. Now let's simplify. So 18 over 72 simplifies down to 1/4. X to the 6th divided by x to the 4th is x squared times y squared. And then for our domain restriction, we just want x and y to not equal 0, because if we put those values in, they would multiply by the other things in the denominator and create a denominator of 0. All right, now let's look at C. So let's start by factoring all parts of the rationals. So we can factor out a 2x, and we're left with x minus 5. Our difference of squares will factor as x minus 5 times x plus 5 times x plus 3 over 2x squared. Now examine your numerators and your denominators. Notice that we can divide out 2x from our numerator and denominator. We'll be left with the single x and our x minus 5s. So we'll be left with x plus 3 over x times x plus 5. For our domain rule, look one step up before we simplified and exclude positive 5, negative 5, and 0. All right, now looking at D, we have a difference of two cubes again. So look at that factoring pattern. So our numerator won't factor. Our denominator, we have an x and a 1 that are being cubed. So it will break down as x minus 1 times x squared plus x plus 1, all times that same quadratic, and we'll put it over 1. So our quadratics will divide out, and we'll be left with x plus 5 over x minus 1. And then for our domain restrictions, of course we need to exclude positive 1, and then we're going to set that quadratic equal to 0 and use the quadratic formula to figure out which imaginary values we'll need to exclude. So we'll get negative 1 plus and minus I times the square root of 3 over 2. Now please remember, because I know I'm going very quickly through these notes, that you need to pause the video anytime you need to, just to catch up, and also if you just need to think about something to understand what's being said. Now let's talk about dividing rational expressions. So to divide one rational expression by another, you simply multiply the first rational expression by the reciprocal of the second rational expression. So you might have learned in an earlier math class something like keep, change, flip. Keep the first expression, change to multiplication, flip the second expression. Rational expressions are closed under non-zero division. That just means a set, in this case rational expressions, are closed under that operation if when we do it, we will always get, our answer will always be a member of that same set, so it will always be a rational expression. To find the domain, we're going to give all the excluded values that we need to. We're going to look at the factored denominator of the first, and then we need to look at both the factored numerator and denominator of the second term. Because we are flipping that expression, both of those have time in the problem as denominators. Okay, so let's look at this problem, and let's start by factoring all parts of the rationals. So we have 7x over, and we divide out of 2 times x minus 5. Now we're going to change division to multiplication, and we're going to flip that expression, and I'm going to factor as I do that. So my denominator will factor as x minus 6 times x minus 5, and my numerator, which now becomes my denominator, will factor as x times x minus 6. So notice that I have kept the first one, factored it all, changed to multiplication, and flipped my second rational, factoring as I go. Now I'm dividing out common terms. So I divided out my x minus 6, and I can divide out my x minus 5. I can also divide out my single x's, and I'm left with 7 halves. Now for my domain restriction, I'm going to look back and restrict anything that's in both of my denominators and also the numerator of my second expression. So I need to restrict positive 5, 0, and positive 6, and that takes care of both of my denominators and the numerator of my second. All right, now let's look at this real life example. So the total annual amount, I, in millions of dollars, of personal income earned in Alabama and its annual population, P, in millions, can be modeled by I equals that rational expression and P equals that rational expression, where lowercase t represents the year, with t equals 1 corresponding to 2001. Find a model M for the annual per capita income. Estimate the per capita income in 2010. And I believe we're actually going to, I think I have this wrong, that it should be corresponding to 2000. There we go. So the first thing I'm going to do is to create that model, that M, for the annual per capita. So that means how much income per person. So that would be taking I and dividing it by P. So I'm going to take the rational for I, which is 6922t plus 106,947 over 0.0063t plus 1. And then when I divide it by P, it's the same thing as multiplying by the reciprocal. So I'm going to think of this as over 1 and then take it times the reciprocal of that. So 1 over 0.0343t plus 4.432. Now, to find the income in 2010, I'm going to plug in, that's 10 years after 2000. So I'm going to plug in 10 for t. Well, first of all, I'm going to go ahead and multiply and just put everything together between my numerators and my denominators. I'm not going to distribute. I am just going to set them next to each other. Now, to answer that question, I'm going to plug in 10 for lowercase t. So my denominator, I have 0.006310 plus 1, and then 0.0343 times 10 plus 4.432. Now, carefully work that on your calculator, making sure that you key it in the right order so that you'll get the correct number, and so you'll, to the nearest dollar, you should get 34,707 per capita income. All right, and that concludes our Concept 39 notes.